Hello, welcome to Learn with PMWds. In this session, we're going to look at Introduction to Object-Oriented Programming in Python, Part 1. Alright, the following are the contents that we should deliver at the end of this course. We'll be looking at classes and objects. We'll also look at classes, method, and static method. We'll look at encapsulation and properties. We'll look at inheritance. We'll look at multiple inheritance and mixins. We also look at polymorphism, special method, abstract base classes, composition, and the last part will be solid principles in object-oriented programming. Right. Before we dive into those contents that we are going to cover, we have to look at the key concepts of object-oriented programming in Python. Yeah. Therefore, before even looking at the key concept of object-oriented programming in Python, we have to know what is object-oriented programming. What is object-oriented programming? So if there's object-oriented programming, that means there are other software development method that we must be aware of. That is, we also have procedural programming. Procedural programming. Okay? We also have this type of procedural programming, and we also have object-oriented programming. Therefore, there is a need to understand these various forms of developing systems. I'll start with the procedural programming for us to really understand what object-oriented programming is. Now, procedural programming is a way of developing software system in a set of interacting functions. Right? In a set of interacting functions. That means from the previous session, and I've understood that you have been creating Python programs through function calls. You all learned fundamentals of Python, and you created functions in order to interact from one piece of software to the other. You used to call the functions. So that's why we are simply saying procedural programming is a way of developing a set of instruction through functions call. Now, the things changes when it comes to object-oriented programming. So now, object-oriented programming is a way of developing software application in a set of interacting objects, right? In a set of interacting objects. So we're going to observe very few things. Now, what is the real difference between these two concepts? Function versus objects, right? Are the things that we are really going to look at in this session. Before we even start programming, it's important we know this aspect. So function, way of developing system, it separates, function separates data and what? And methods. Yeah, we really don't care about how we define this, but all we are saying that functions separate data and methods, while objects, it requires that it knows what data it's working on in their functions. So in short, that in object-oriented programming, we'll be developing software in objects, and we know that object contains data and methods. Unlike for functions, you are defining method without knowing which kind of data they must operate on. So the method were separate on their own, and the data, or in short, attribute, were separate on their own. Okay. Now, like we said, the key concept of object-oriented programming that we must know. And these are the things that we already know in real world scenarios. The first one is class. We have to know class is important in object-oriented programming. We will look at object, encapsulation, inheritance, and you are so familiar with these terminologies. So now we are just putting it in software development way. You have also heard of polymorphism somewhere, right? Okay, so we'll start with a class. What is a class? We'll start with a class. Simply, in simple terminology, a class is a blueprint of an object. A class is a blueprint of an object. For now, the definition sounds so abstract, but we are really going to understand what this means. But for now, we're just saying a class is a blueprint of an object. Yes. Then, what is an object? So, an object is an instance of a class. And you're going to be surprised how these definitions are interchanging. The class, a blueprint of an object is an instance of a class. My bad, what this is. So now, we also have to look at encapsulation. By definition, we are simply saying encapsulation is binding, right? Binding data and methods in its objects. Yeah, actually, this is a flow of things that we really need to know and understand, because knowing this concept, they are going to help us in programming, in creating software application using object-oriented programming. Then we move to inheritance. We move to inheritance. So, what is inheritance? Simply, inheritance is where a parent passes its function to a child. So where a parent passes its properties to a child class. As simple as this. A parent class passes its properties to a child class. That means a child class inherits everything that a parent has. And in the real life, we don't inherit everything about my mother and my dad. It's just certain attributes. So we complicate this in object-oriented programming by saying that away from real life, we are saying that the child inherits everything that the parent class has. And we are really going to understand those things. So now, polymorphism by definition, right? So polymorphism is where now a one instance of a class can be called in a different way, or is where an instance of a class behaves in multiple forms. Yeah. So we are not really people of definition. We know that, but it's important to understand this small basic definition, right? Yeah. So as we are saying, we are now starting. We're now starting classes and objects, and remember, this is a part a part of the key concept of object-oriented. So now we start looking at this in detail so that they marry with our definition. Okay. As we are saying, a class is a blueprint of an object. As a blueprint of an object, imagine this is just a design that's been presented, right? That make the actualization of an object. An object, we understand that an object represents a real world what entity or real world thing. So now an object, a class is more or less like a design, right? So this is a blueprint, and we have observed that there are architectures who design architectural designs. So after they design one thing, then they can form object. So now this is an object that was created from a class for me. And for diagrams, you have to understand I'm not an architecture, but I'm just a programmer. So all we are saying is that these are objects that were created from a class. This is a class. It's just like a design on a paper. My bad. This is just a design on a paper. Having that design, we can create objects. So this is a house. Now we give to a contractor, and the contractor creates a existing house. So we can create more than one house, just like police compound. Those things have same design. Yeah. So they had only one blueprint, and they created more houses. So those houses are objects. They are real thing that we can touch. An object is just more like a what? A paper. Anyway, welcome to Python, by the way, in object-oriented programming. That is, if we can create classes, that means we can create objects. From object, then we can practice what object-oriented programming is. I hope you follow this way. So the first thing that you need to know, you have to understand, what do I really need to do? That's a class. From a class, you'll be directed to what you should do in an object. Having created an object, it's a thing that you realize that, oh, this type of programming is called object-oriented programming. I hope you understand that part. So it's important to know how to design a class. How to design a class. Because we are saying this is a blueprint, so you have to design. It doesn't really require that you have knowledge about architectural principles, construction, what. No, this is just programming, by the way. So we just copying and pasting to what we can actualize in objects. So if you can't design a class, then you can't create an object. So that means this is a design of an object, of a class, of a class. Yeah. So actually, class, which is a blueprint, which is a design, it basically looks like this. It basically look like this. So whenever you have this design, and this is what called the class name. So here you put a class name. So a class has got three parts. Class has got three parts. Okay. So in A, you put a class name. Then in A, you put attribute or data. We call them attributes. Then the last part of the class, a class contains what? Contains method. Yeah. And this is not strange because you have been doing so. A class name is where you put a class that you have been creating. So book.py, right? So now that book.py, inside the folder of book.py, we combine attribute. So this attribute is another way of saying variables. And you know how to create these variables. And this part we are saying method is where we contain functions, right? Functions. And you have been creating these. That's why I'm saying there's nothing strange about this. We are now just shifting to change of terminologies. You know what attribute is? Attribute is variables. Functions are same as methods. Nothing strange from there. Okay. All right. So I want to point few things here based on our key concept of object-oriented programming. Therefore, we are saying, so since we have this part of a class which has got three parts. Mind you, this part, attribute and method, it's what we defined as encapsulation. So what we defined as encapsulation, that is data binding data and method in an object, right? So here we have binded. So when we define a class and we structure it this way, that means we have already created an object in real life time, right? As we defined, an object is an instance of a class. So I like putting these things, an instance in form of an example. An object is an example of a class, right? It represents a certain design, that is an object that we are going to be creating in our programs. Okay. So now I just created, this is a structure of a class. Now let's make something so real in what we are going to practice this in the next coming session. So I'm creating a customer class that contains name to have got its attribute. This class will be collecting the customer name and the address and their phone number. So this is called, will be called the customer.py. Please pay attention to this because we'll be using this kind of approach in order to do the programming in Python or in PyCharm. As we said, these are attributes that we must define. So a customer will have a name variable. A customer will have an address. A customer will have a phone number. Okay. So this customer is going to be initialized. It will have this special type of method. And I won't explain so much about in this part because there's another part where we have to introduce types of method. As we are saying that in here we have method, but there are lots kind of method. So bear in mind, we are just going to collect this name. We're going to create connect address and phone number, right? Then we are going to also to call to collect to set the name variable. Set name. We are also going to find set address. We are also going to define set phone. Okay, and we are also going to get name. We're also going to get address. That's it. We're also going to get phone number. That means we're done. So as we are saying, we specified in there that a class blueprint contain attribute. These are attribute, the variables, and the class contain method. These are what? These are method that we have defined here, right? Yeah. So this is basically a blueprint of a class, which is an object. A class is a blueprint of an object. So this is just a blueprint, a design that we must now actualize in a real world programming. Okay. Why are we doing this? Why can't we just create a program? All right. Now let's describe the laws of a class. Here we're going to say laws or access rule about these classes. Through what we defined as encapsulation, So encapsulation does not allow variables or attribute to be accessed or modified by outside entities, but only its methods. So the key point here is this. So these variables can only be accessed or modified by the method in E, but they cannot be accessed or modified by any other method apart from the methods inside its class. These are the methods which are part of this class. So these attributes can only be accessed by the method in E. I hope you understand that. So these are the rules that we must never bypass, by the way. Therefore, so we have defined this variable. So to for me to initialize or to pass its value, I have to pass it through a method. That's why we are saying set name. An example of this that I'll give directly for more understanding, we usually define variables like name is equal to PMW. We like doing this. And in object-oriented or in classes, we shall never do this in lifetime. We cannot assign a variable direct to this name, but we have to use a special method in order to assign that variable. Assign, it's just passing the value to a variable name. So we can't do this directly in object-oriented. For me, just to assign this variable, I have to create a what? A method that is assigning the variables. So for example, before we go very far, we are going to create this class in a program, but for sake of illustration to what I'm talking of, we have this set name method. So it's a function which will be defined like set name. Set name, self name, then that's when we pass the variable name is equal to this name. Name is equal to, so let me just highlight it in a different way. I'll put it as n, so that we say name is equal to n. We are done with this class definition. Def set name self n, name is equal to n. That means when I call this method, it's going to, when I call this method and pass an argument will be any variable name, and that n will represent, will assign this variable to n. That means whatever n is going to possess, that's the name is going to have. That is outside the program of that class. Then I'll call this method like set name. Then I'll pass the variable n. So n is to pass an argument, of which we know that PMW swirly, like that. Then that PMW swirly is going to reference to that n and pass the variable name inside that class. The key concept of object-oriented programming, and we defined what a class is, and we defined what object is, and other key concepts. In the next session, we'll be looking at class and object in Python. So we'll be creating all these in what? In Python. Okay. Now, for the sake of clarification, we introduce what was called a blueprint of a class. So this blueprint of a class, or this type of modeling, is called the UML, Unified Modeling Language of a Class. So that means if you want to design better classes, you have to know this kind of setup. And we said that we have said what this class is made of. I wanted to clarify this type of modeling, which is called the Unified Modeling Language. All right, we're done then. See you in the next session where we will practice a customer class in programming, and we are going to create that blueprint and we call objects in classes. See you.